Hi folks, it's Dr. P. In this video, I want to give you an overview of the different simulation options that are out there. Each one has its own pros and cons and is beneficial in different ways. In each simulation tool, I'm going to show you how to connect a simple AND gate circuit. The two inputs come from a dip switch, and the output goes to an LED. The first simulation option I want to discuss is called Tinkercad. It's a website hosted by Autodesk, which is a popular CAD company. It's free to create an account. When you first log in, a column on the left-hand side gives you options. Click on Circuits. I have a whole lot of saved designs because I've been using Tinkercad for a few years. It also has the benefit of having an inbuilt Arduino, so that's really nice for my microcontrollers class. Let's make our AND gate circuit. The great thing about Tinkercad is that building our circuit here is almost exactly like how we would build it in lab. I find all of the parts that I need: dip switch, pull-down resistors, 7408 chip, LED, and current limiting resistor. I'll also need a power supply and breadboard. Then I just place each piece on the breadboard and connect with wires. I can even change the colors of the wires to red for VCC, black for ground, and whatever colors I want for all of the other signals. I can change the value of each resistor to 220 ohms. Clicking on the Simulate button, I can then change the values on the dip switch to see what happens with the LED. So the great thing about Tinkercad is that it helps you with actual breadboarding skills. Many students struggle with the breadboard at first, so if you fall into that category, building circuits in Tinkercad before lab and using it as a reference is a really great idea. However, Tinkercad has very limited parts and gets very slow once you start putting in a lot of components. So this is really not the greatest option for your design project, but as mentioned, it's a great resource for helping you get acquainted with breadboards. Next up is CircuitVerse. CircuitVerse is also an online simulation tool and is also free once you create an account. As I place components into the CircuitVerse simulation, one thing you'll notice is that CircuitVerse looks a lot more like a circuit diagram than like a circuit that you build on a breadboard. So it uses abstractions, pictures of logic gates, rather than actual logic chips. It's not bad, but it means that if you want to build something from this eventually on an actual breadboard, you need to understand how to go from these pictures of logic gates to a breadboarded design. Also note that I didn't have to place any resistors in my CircuitVerse simulation. That's because it doesn't really consider current flow. It's just looking at digital logic signals of 0 and 1. Now, if I were to build this circuit on a breadboard without resistors, I'd burn out my LED and melt some holes in my breadboard near my dip switch. So again, this isn't really a problem as long as you understand the practical physical limitations when using this to help aid in an actual built design. So I'd say that CircuitVerse is great to use when you want something that looks more streamlined, runs faster than Tinkercad, has a lot more parts. The other cool things are that you can make sub-circuits to make the layout less massive if you have a complex circuit. CircuitVerse is a really great option when you want to test and see if a design works, but you're going to need to rely on your breadboard skills if you want to build that design. CircuitVerse is slightly limited in how many devices it has, and can be a little tricky if you need to use buses. However, you can find plenty of tutorials to help you out if you decide to use CircuitVerse for your design project. Logisim is the next option. Logisim is a piece of software that technically runs on Windows and Mac, except that it needs Java to run, so you probably won't find a Mac that'll run it. It's also no longer being updated and supported, so while it's really good, it won't get better. And the best part about it is that it's completely free. Thankfully, I have a Windows laptop that I can use to run Logisim. You'll note that it uses logic gate abstractions like CircuitVerse does. So it's going to give you that cleaner kind of circuit diagram look when you build a circuit. There are also more options with logic devices in Logisim than with CircuitVerse. So you're going to see things like expandable ROM and so on. Choosing between Logisim and CircuitVerse is a matter of how comfortable you are with each platform. In addition, if you don't have the option for some type of specialty logic device that you need in a project, you need to know how comfortable you are implementing it. For example, The 74194 Universal Shift Register isn't a chip that I can plug into either of these tools, but I could build one using D flip-flops and logic gates. I might decide which of these software tools to use based on how easily I can recreate that functionality of the 74194 chip. Choosing between these can also be a function of, do you have a Windows computer that you can use? If not, CircuitVerse is going to be the best tool for you. Lastly, there's the big kahuna, NI Multisim. I love Multisim. I've been using it for years. If it's so great, why am I bringing it up last? It costs money. Even the student version is usually between $40 and $50. So I would never mandate that you use it, but I do want to discuss it, especially if you think it could help in future electrical engineering classes. It also only runs on Windows, which I know can be a deal breaker if you're a Mac person. Multisim is different from the other tools because it actually has all of the 7400 chips that we use in lab. This means that I can drag in the 74 LS08 chip, a dip switch, resistors, and an LED. And that way it's kind of like Tinkercad, except that I don't place pieces on a breadboard. Multisim knows how all of these chips work internally, so it has the most accurate representation of current, voltage, and timing in each circuit. I've used Multisim to do a ton of digital logic design. I used it to design a really complex multiplier circuit. I've used it to simulate a lot of the more complicated labs that we do before I actually built them on a board and wrote up the labs. So it's really great when you know that you actually want to build something on a breadboard and want to build it as accurately as possible in simulation tool beforehand. The other great thing about Multisim is that you can see all of the pinouts on your schematic. I keep all of the schematics that I build in Multisim in my design notebook, and I use them when I'm building a circuit on a breadboard. I can read the pin numbers and I know exactly what to connect everything to. Remember how I said that in CircuitVerse or Logisim, you'd need to figure out how to get the functionality of a 74194? In Multisim, I can just drag and drop the part. It's that easy. So it's a lot simpler to use when we're getting to a lot more of the complicated digital logic devices. So if you don't mind spending the money, Multisim has the advantage of having a ton of parts, having a very realistic simulation interface, and giving you all of the chip pinouts. It's a cinch going between a Multisim schematic and a project on a breadboard. So how do you ultimately choose which software tool you want to use? Well, pick a circuit, probably something a little trickier than an AND gate. Find something we did in a lab that maybe took a little extra time to build, and then put it together using each of the free simulation tools. Once you do that, you'll get a good feel about how each tool works and which one you seem to like best. Don't wait until the design project is due to get started simulating stuff. Start on day one, and that way you'll build experience. It's also totally okay to pick one tool and then change your mind once you start working on your design project. Okay, folks, I hope that helped you to better understand the simulation tools that are available to you in digital systems. Until next time, stay well.